Good morning, everybody. I'd like to welcome you to Microcom's webinar featuring LightPointe optical point-to-point links here. We've got John and Brian on from LightPointe, and they're going to be actually showing us a live demonstration today. So let me set this up here. Going to Brian, and yes. Okay, Brian, you should have it.
It says show my screen. Let's see what I got. Assuming everyone can see my busy screen now?
Yes. Real quick, if you guys have any questions, just go ahead and type them in the question box on your screen, and we'll have a question and answer at the end of the presentation.
Thanks, Jeff. Thanks, Jeff. This is John Taylor with LightPointe. We thank Microcom for inviting us for another webinar, and we appreciate everybody's attention today. This is the second in a series of webinars that LightPointe has been doing this year, and we've got some more planned follow on this year. My name is John Taylor. I'm Vice President of Sales for LightPointe. The first webinar earlier this year was on FSO, free space optics installation and best practices. If you missed it, we recorded it with Microcom and posted on the webinar on the YouTube channel, along with other instructional and product overview videos that we have on YouTube. Today we're going to present a short demo on the patented hybrid system called the HiBridge. HiBridge is a rate adaptive, multi-frequency Gig-E wireless bridge that is always on. You never lose connectivity, and it provides longer range than 60 gigahertz radio bridges. Customers are sometimes afraid of impact of what weather will do to FSO. Some of our radio 60 gig competitors like to exaggerate the potential availability issues with FSO. The LightPointe hybrid system can give you full duplex Gig-E, longer range and versatility than 60 gig radios. Through the end of May, HiBridge SXR5 is part of a promotion we're doing. We call it the 5 nines promotion, 5 nines for 5 nines. So instead of $11,900 for a wireless bridge, the HiBridge SXR5 is $9,999, and that's through the end of May. The HiBridge demo will be presented by Brian Peterson with LightPointe Customer Service, and please type in your questions. We'll answer them at the end of the webinar.
All right, thank you, John. Well, welcome to our webinar. As you see on the screen, and John mentioned, this is going to be specifically about the HiBridge products, and the product we are going to demonstrate is the SXR5, and we'll talk about that as we go through this. So the object of the HiBridge product is to provide you with a laser, full gigabit, full duplex solution as your primary link. So during clear weather, you'll have a full gigabit of throughput doing full duplex. During the rain, you'll still be able to maintain signal strength. We are not affected by rain as much as by like fog. So even with rain, you still will have your full duplex operation. We can even pass through light snow and still give you the laser-based connection, still giving you gigabit full duplex connectivity. However, should the weather get severe, whether it be from fog or heavy snow, sandstorms, whatever is going to reduce the visibility and attenuate the signal to a level that it goes into, well, we set it actually at about 2 bars of signal strength. When it hits that level, or 250 millivolts, it automatically switches over to our RF backup. And it'll stay on that RF backup only as long as that severe weather is impacting the FSO. So within the unit itself, we are constantly monitoring the current signal strength, called the RSSI level for us. And when that RSSI level increases to a number that's been preset to 300 millivolts, the unit will then instantly switch back to the gigabit connection. Now during this switchover, you may lose 1 ping, at the most 2 pings of data. but you won't be dropping your VoIP connections, you won't be dropping any of your sessions because the switchover is so quick. In fact, we are quicker than rapid spanning tree, which makes this, and we're integrated. So you don't have to wait for a lack of hello packets. As soon as we see the issue is reached a severe level, we change over, and then of course we change back. Now we do have different models available based basically on what you have currently installed, how far you're going, and what your desires are. So going from left to right, we have the product that John was referring to in our 5.9s for 5.9s solution. Will transmit with a single receiver. It is full duplex gigabit, and it has the backup radio integrated as you see here. Let's see if I can get my, there we go. As you can see here, the radio is attached to a bracket that hangs just below the FSO unit and is automatically integrated. It's got PoE built into the unit so that it powers up the radio directly from the unit itself. Now, if you currently have an RF solution on the roof, you can use our SX product. And the big difference between the SX-R5 and the SX is the SX lacks the built-in radio. It's what we call radio ready, meaning it still has a connector on the bottom that will allow you to plug a radio in. You have a toggle switch on the rear of the unit to determine if you want to provide PoE to your radio, 48 volt PoE, or if you don't want to, if your radio, for instance, doesn't accept 48 volt, or it has some other proprietary requirements, you can just pass the data through that bottom port into the PoE of your whatever radio you might be using. So the benefit of the SX is you can go ahead and use your existing RF solution that's on the roof and just put us into as an addition. Now we will operate next to it. As you can see from our SX-R5, we actually can interoperate with an RF product where we are basically less than an inch away from the two units without interference. Now the SX-R5 is rated to about 750 meters. The SX by itself is really a 500 meter product. I should also mention that in both of these units, if you are going a very short distance, we created a wider beam product, which is basically the SX-R5 wide beam or the SX wide beam. Not to confuse things, but the shorter the distance, we want to widen the beam, so we created a wide beam. If you need to push the distances a little bit further, then you have the standard product. If you need to go even further than that, that's when you get into the LXR5 and the LX. In essence, the same idea. You have a radio built in and attached to the unit for the LXR5, and on the LX it is strictly radio ready. The difference is now you're looking at about a 1600 meter, basically doubling the distance with the LXR versus the SXR. So depending on your distance, depending on your application, we do have different opportunities and options for you. I'm going to now switch over to the other half, which is to tell you a little bit more in detail about how the product, how the switchover and the product actually functions. And then we're going to do the live demo during this part of the presentation. So what we have moved to, for those of you who are familiar with some of our older products, is we didn't have a web interface. We now have a web interface called the Air Manager. It allows you to easily access the unit through any web browser. It is a Java application, so all you have to do is have Java on your units or in your network on the computer that you're going to be accessing, and you'll be able to see and monitor the unit through the web browser. We do, of course, have built-in SNMP, and we now have syslog. So really we have three different ways that you can monitor the unit remotely. You have the web, SNMP, and syslog. The units themselves are fairly easy to program. Once you've logged into the unit, all you have to do is make your adjustments in the various web browser interfaces. Primarily, you can do your management, setting your IP addresses. You can upload, when we have new firmware, you can upload that firmware through the software. You can go ahead and verify your settings or change your settings for your failover. It also allows you, here you can see the RSSI current value. You can see alarm traps here, loss of signal, overload, etc. So in general, the web interface is a very user-friendly and informative place to find all the data that you require. Now, if you do choose to do SNMP, we do supply you with 2 proprietary MIB libraries, one for the specific product that you have, and one is our general SNMP MIB library. Both of those can be then loaded and compiled into your SNMP browser. For us, we use MGSoft, but obviously if you're using SolarWinds, if you're using HP, any of those can allow you to load these MIBs into your browser or into your SNMP software. So what we have in our office is a situation where we have 2 FSO units pointing to each other in our hallway. This particular unit here, the one nearest to us, has a camera pointing to the rear of the unit. It is not connected to the network directly. The only access that this unit and this camera has to the network is via the remote unit. So if this unit goes down, we don't have, then the radio will kick in. And we're going to go switch to that in 1 second. I think John is eavesdropping here, so he should be heading out into the hallway. So that's our live image. Here is my syslog server. Here is my SNMP. And then here's my pings. So we should be able to see John heading out to the hallway here in a moment. You can see it's live. We've got little blinking lights here. And there's John blocking the beam. There's my alarms. There's my timed out. I've lost 1 ping. The pings are back up and running. John, keep that up for now. And you can see, there he goes. So now our FSO is back. Our loss of signal has gone back to normal. Our copper port redundancy is now back to normal. Here's our traps. And the unit is functioning back over. So we lost 1 ping when we blocked it. We lost 1 ping when we removed it. John, you want to do it one more time while we're still going? And there he is, right on cue. So again, you see all the alarms clicking in. We lost 1 ping as the unit failed over to the radio. You can see we're in loss of signal here. John has removed it. Loss of signal has gone away. There's our ping that we lost as it failed back over to the FSO. And when he removes it, once again we're back on the FSO. So the system itself is very quick in the way that it fails over to the radio, and very quick in the way that it fails back to the FSO. The whole design of the system is based around quickly switching over and maintaining your primary link, your FSO link, as much as possible. So I'll come back over here, and that's what we saw here. Is we had this link going. John would block the beam here. When he blocked it here, we would go to the radios, and we would be traveling over the radios while that piece of cardboard was blocking the FSO. As soon as the FSO unit is unblocked, it switched back over, and we went to our primary on the laser-based solution. So this is kind of what we saw. We had the TrapRinger console up, we had our syslog server, and we had a constant ping going the entire time. Now this unit has been, and this solution has been available for, a few months now. And so these are some customer installations to give you ideas of what they've done. Now again, customers have preferences. The radio that we use is a 5.8 gigahertz. Some countries don't allow 5.8. Some places it's not a frequency they like. You have a preference of a radio. You use a specific Landcom radio or a Ruckus radio or a Ubiquity radio that's different than the one that we supply. Whatever the case is, we're happy to work with what you've got, but if you would rather have a solution that's integrated, so you have no thinking, no additional configurations required, then of course you can do our integrated solution. And we have an image here of the LXR5. Here is the SXR5. And then we have various installations where customers have used their pre-existing radios. Now, at this point, that would be the live demo and the slides that we wanted to talk about for HighBridge. If I went too quick over something or you have questions, I'll go ahead and turn it over to Jeff and say, are there questions?
Okay, I got a couple things here that came up on it.
Okay.
And one of them was the, first of all, is the promo will be available on Microcom's website here, so that information will be out for people as well. And the other part, and the other question I had for it was, what parts come with it, with the link, what type of mounting equipment comes with it?
Okay. The parts of the unit that you saw that were white during those presentations come with it. So you get what we call a universal mounting kit, which is a base plate, a 2.5-foot pipe, a cap, a pan and tilt, and then the head itself. So the universal mount is designed to mount either vertically or horizontally, and we do have a couple solutions. Again, if you go to that last webinar we did about the various types of mounting solutions for FSO, you will see various options for how to mount the units depending on your specific application. Of course, John and I are both available if you have a situation where you have questions or you have a specific installation location that seems obscure or curious. Let us know and we're happy to help.
Okay, and then is there, in a power failure situation, do they come back up? Do they need to be rebooted? What happens with power failures?
Okay, good question. The units are actually fairly low powered, so I would recommend that you throw a low cost UPS on them. We use a 685 amp UPS, and we get about an hour to an hour and a half of runtime on these units with that. So for a $90 investment, you can definitely save yourself a little bit of headaches if you have power outages or frequent short power outages. However, once the power does go out completely, the units are stably mounted, so as soon as they come back on, you'll have a boot time where takes about 35 to 40 seconds before traffic will start to pass again once the power comes back on. And then the web interface will be available after about 2 minutes.
And then speaking of that, for solar applications, what are the draw? Is it a DC? Is there an AC/DC converter on it, or how is that?
Sure, it's a 48 volt PoE so it runs off of PoE, and it's a 48 volt mid-span, 1.1 amps required. If it does take direct 48 volts, so if you have a 48 volt source, you can power it directly with 48 volt. But from a solar perspective, yeah, you want to make sure you can give it about 1.1 amps.
Okay. Does anyone else have any other questions? Okay, I'm not seeing anything else popping up in here. So,
Okay.
John, Brian, I'd like to thank you very much. The demonstration on it was great. And if anyone has any questions, you can contact your Microcom sales rep, or you can also email sales@microcomtech.com. Or as well as, like we talked before, this presentation will be up on our YouTube page, so you can see that. You can go to YouTube and search by LightPointe, as well as search by Microcom, and this will come up with our other ones we've had. And any questions, again, like I said, feel free to contact us, and have a great day. Thank you very much for joining.
Thank you, everyone.